Okay, everyone, attention please. So this is the fifth lab of the FC1 class. Today our topics are minerals and abstract rewrite. Let's first take a look at the abstract rewrite. This is a task due next Friday. So you have 2 weeks to finish the rewrite. So in this rewrite, you need to first find a research paper, a journal article, which is related to the book, to the science book you choose on the first 2 weeks of this class. So find a research article and rewrite the abstract of the articles. I will show you how to find the scientific paper. So usually we use this Google Scholar to find the paper we want. For me, if I'm interested in the topic of earthquake, just search the earthquake and it will lead me to a website. It lists many papers and some of them are actually books. What we want is the journal article. So let's first try the first link, the earthquake mechanism. So this is a journal named Tectonophysics. You see the title of the article, the order of the article, and then is the abstract. So this abstract summarizes everything in the paper, summarize the data, the method they used, their scientific findings, and their conclusions. They summarize in the abstract. Your task is to rewrite the abstract into plain language version to make it understandable and readable to non-expert people, to non-geologists. Yeah, so go to the Google Scholar, searching using the keywords from your book. Find an article relevant to the theme of your book and locate the abstract. You can easily see the label abstract. And then if you don't see the abstract, then you should not use it for your rewrite. Rewrite it as you are the author and possibly reorganize the abstract in plain language so that non-geologists can understand the word. And finally, in your submission, you should submit a Word file or a PDF file. A Word file should end with like .doc or .docx, so it can be opened on all machines, both Mac and the Windows machine. Or you can just submit the PDF file, also can be opened on all machines. In your submission, you should include the original abstract and the rewritten version and the link to your article. We want to show you an example of the abstract rewrite. This is a paper published on Nature Geoscience, which is a very good journal in earth science field. So this is the abstract of the article. Let's attempt to rewrite the first sentences. The first one is the steep topography of the mountain landscapes arises from interactions among tectonic rock uplift, valley incision, and landslide erosion on those slopes. So for these sentences, the word topography, this topography word is too technical for non-expert people. So we can first try to remove the word topography, and it becomes the steep mountain landscape. So it still looks good and has the same meaning with the previous one. So we can rewrite it as steep mountain landscapes. And then the tectonic rock uplift. The word tectonic is also too technical. So we can try to remove that. The rock uplift still has the same meaning. So we can just use the block uplift. The value insertion. Insertion is also too technical, but we cannot simply remove that because the value has the different meaning with value insertion. So we replace it with the word reverse deepening channels. This is more general and more easy to understand for non-expert people. For landslide erosion, we replace that with landslide erosion. So after that, we finish the revision for the first sentences. Following this rule, you can finish for all sentences in the abstract. Some tips to make sure. First, make sure you find a paper, a research paper has specific finding. Sometimes when you search on Google Scholar, it gives you the review paper. The review papers are those summarize or synthesize previous findings. These review papers are not good for our class, so you should find a scientific research paper. And please keep all main points in the abstract when you do the rewrite. You may need to smooth the sentences out and keep in mind the paper you find, the article you find need to be closely related with the book you read. So you can integrate them into your book presentation. And the length, the word number should be between 250 to 500 words. We don't want it to be too long. So after you rewrite that, check the word number. Make sure it's within this range. Your final submission should be like this one. The title of your document should with the name, your first name, and your lab sessions and the abstract. The first two lines are your name and your lab session. The third line is the article name you find. The fourth line is the article link. And then is the original abstract. You can just copy and paste from the original article. And then is the part you rewrite, the plain language abstract. So your rewrite should be followed here. The deadline for the rewrite is next Friday for our last sessions. Last year, when we taught this class, we found many students they choose article not very good, not suitable for this class, maybe not related to their book, or it's not a research paper. So we want to approve before you begin to rewrite. So after you picking your paper, send the title, send the link, and send the abstract to us. We will reply you very quickly. Either say, yes, this is good, you can choose it to rewrite, or we will say, oh, sorry, this paper is not suitable for our class. You need to choose another paper. So after you get approved, you can begin to rewrite. Then next is the formal part of today's lab. Today we do the mineral identification. So you have seen we have in total 18 mineral samples on all tables. So your task is to try to match the sample with their names. So here we have sample 1 and the mineral. You need to match the mineral with their names on this table and finish the lab assignment. The lab assignment is about the mineral identifications. Let's first look at what's a mineral. Usually mineral have 5 main characteristics. First, it needs to be naturally occurring. So it's generated naturally. It's not made by human beings. Second, it needs to be inorganic. So it's not organism. And it needs to be solid rather than the liquid or the gas. And it have definite chemical composition. It means you can write the chemical formula for the mineral. We have a very famous mineral called gypsum. Gypsum, so it's the name of the mineral, and the chemical composition of the gypsum is CaSO4. You can write the chemical formula. And minerals, they usually have ordered internal structures. One confusion point is the rock and mineral. They are 2 different things. This is a figure of the granite. So this is a rock. This rock actually is composed of 3 minerals. We have quartz, we have feldspar, and we have mica inside the rock. So the rock is a solid mass composed of a combination of minerals, and sometimes has other organic compounds. So next, I will teach you how to use this flowchart, this table, to identify the minerals. We check this aspect, the luster of the mineral, the hardness, the color, the streak, and the crystal form, the cleavage. Cleavage is very important for mineral. The density, how heavy it is, and the other things like taste, the odor, magnetism. Be careful when you do this kind of taste test, because some minerals, they are harmful. So do not do taste test if you don't know, don't clear what it is. So we began from the luster. We observe the mineral to check whether it's metallic or it's non-metallic. Here we have 2 large groups. This small group, this is metallic luster, and the other, they are non-metallic luster. So if you find a mineral, this one is non-metallic, so you should go to these 2 parts of the table for next step. The hardness. Usually the next step is to check the color of the hand thumb. For this one is light color. So the light color is the left one. Sorry, the right one, this figure. So you should look between this light color minerals. Please. And then next thing is to check the hardness of the mineral. To check the hardness, we have some criterions. Like the hardness scale here, we divide them from 1 to 10. 1 means the softest, and 10 means the hardest. So talc is the softest mineral, and the diamonds is the hardest mineral. We have some common objects you can use to test. Your fingernail, the hardness is 2.5, and the copper penny, the hardness is 3.5, and the glass plate, this one, the hardness is 5.5. When you do the hardness test, you try to scratch, try to move on the glass plate, and you find some white things left, and it can be easily removed. So this is not a scratch. But if I try to scratch the mineral using the glass, you see some obvious scratch on the mineral, right? This means the glass is harder than this mineral. So which scratch is harder than which has been scratched? That's for hardness. And then the streak, another important thing is the streak. So the streak is the color of the mineral when it is pondered. The streak color is not always the same as the hand sample color. To check the streak color, you stretch the mineral on a white plate. The color left on the white plate is the color of the streak. So the streak color is another important evidence we use to identify the mineral. After you decide the luster and the light color or dark color, you test the hardness to see whether it's harder than the glass or softer than the glass. The next thing is cleavage. Cleavage is another important thing we do to test. Cleavage. Like we have a mineral. If you drop that to the ground, or if you destroy that with a hammer, you will find the mineral tends to break at a certain flat planar surface. It tends to break along a flat planar surface. That surface is called the cleavage. This cleavage is decided by the internal structure of the mineral. The way we check the cleavage is put it under the light and try to rotate it. At a certain angle, you will find the surface become very shiny. It will reflect the light as a mirror. So this is a cleavage plane, and you have light. It will reflect this light as a mirror. So in your eyes, you will see it very shiny. Sometimes the cleavage is not a regular band. You will have this kind of steps, but you can still identify some bands that reflect the light. So these things, they are also cleavage. So use the lights and the reflection to identify the cleavage. If it's one cleavage direction, it means the structure of the mineral is layered. One layer, many layers. If it has two cleavage, then the two cleavage has direct angles in between. If they are perpendicular, that means they are 90 degree. If it's non-perpendicular, it's not 90 degree. If it has three cleavage plane and they are all 90 degree, then we call it cubic cleavage. And sometimes we also see non-vertical cleavage. Like the cleavage plane angle can be 90 degrees, or sometimes it can be 120 degree and 60 degree. For minerals, don't have cleavage. When you try to break them, the breaking surface will be irregular. Like this figure, the breaking surface is very irregular. This surface, we call it fracture. So it's very different from cleavage. Another thing is the crystal form. For some mineral, we also have very smooth surface and a very shiny surface. The appearance of this surface look like cleavage, but actually this is not cleavage. It's the crystal. The difference between cleavage and the crystal is that when you break a mineral with cleavage, it tends to break at the surface of the cleavage. It will form new cleavage then. But for crystal, when you break, the breaking surface is very irregular. The breaking surface is fracture. So next I will show you how we use the angle of cleavage to distinguish between two minerals. So you see the color and the shape of these two minerals are very similar. Actually, one of them is pyroxene, the other one is amphibole. They look similar, but the amphibole has a cleavage angle of 120 and 60, but the pyroxene, it has 90-degree cleavage. So if you measure the angle between two cleavage planes, you will find this one is 90 degrees, so it belongs to pyroxene. And this one, you will find 120 degree and the other 60 degree. So it belongs to the amphibole group. For this week's lab assignment, so it's week 5 minerals. Let's see. For question 1, answer the question 1 with the mineral, with one mineral in front of you, the mineral close to you. Just choose one. One is okay. And for all other questions, you need to match the sample with their names. For question 2, you match sample 1 with its name, and then sample 2, sample 3, until sample 18. For half of these samples, like 9 questions among them, we have physical tests. You can check your answers. Like I choose any one. I choose this sample, this mineral, and you can grade identification. If your name is wrong, it will show you missed the mineral name in the list. If you choose the right name and grade again, the mineral name do not appear again. And you can also test other things like the color. Now I don't choose any color. I grade the color. It told me the color is wrong. If I choose green, which is the color of the mineral, then the green does not appear. It means I'm correct in the color. You can also do some hardness test. Like I want to compare its hardness with level 3. I click 3, and it says the sample was not scratched, so it's harder than 3. It's also harder than 4. It's also harder than 5. When I try 6, it says the sample was stretched, so the hardness is between 5 and 6. If you click cleavage test, it will tell you how many cleavage it has. And the streak test, the color of the streak will show. The magnetic test, it will tell you whether it's attracted by the magnet or not. And the sample numbers here, they are not correct. They don't match the question number. So discard this part. We don't need this sample index. Yeah. This for like 9 out of 18 questions, we have this kind of physical test. For the other half, we don't have a physical test. We only have a 3D model. So if you open the link, it will give you a 3D model of the mineral. You can either like zoom in, zoom out. You can rotate the mineral to observe the details of the mineral. And So this is for lab 5, and the abstract rewrite, the deadline is next Friday. And remember to send us the article name, the abstract you want to rewrite. We will give feedback to you as soon as possible to make sure you have enough time to do the rewrite before deadline. And the final presentation time sign up. This morning we sent an email to every student. Saying that the book presentation time can be signed up now. So if you open this link, you can choose the time to do the presentation. Remember, even though you present like on week 8, you still need to attend week 9 and week 10's lab. We have attendance credit for all these 3 weeks. So like you present on week 8, you also come week 9 and week 10 to listen to your classmates' presentation. Okay, and for the mineral identification, we have some special tests. We have a magnet here. For some minerals, I think only one of 18 minerals, it can be attracted by the magnet. So if you want to do this test, take the sample to the desk. And the acid test, I can do it for you. If you need help, just for me, I will do it for you. Okay, so for the rest of time, first begin from the sample in front of you, and then move to finish all 18 identifications.